Hello and welcome to the computer learning class by Accelerate Computer Systems. My name is Arun and I will be your trainer today. Today we will continue exploring IP addresses. In the previous video we talked briefly about the history of IP addressing and got introduced to two types of IP addresses, IPv4 and IPv6. We will further dive deeper into IP addressings today. Let's start our journey. As we saw in the previous video that there are two types of IP addresses, IPv4 and IPv6. Before we go ahead and learn more about IP addresses, let us try and understand a very important concept. To be able to route data or send data correctly to the correct host or correct computer, the IP address needs to clearly identify a network address and the end computer or host address. You might ask, why do we need to have network address and host address? Let's find that out. We know that to be able to deliver a packet correctly, we need to have a network address and a host address. Let's understand this topic. This is an important concept and we should know about it in detail. Network address is more like a street address and host address is like your home address, which is located in that street. And as we know that both of these addresses make up an actual address, and this is important. Let's look at this map. Here we can see that we have East Street, West Street and North Street. Look at the house numbers. On every street the numbers start with 1 and go up in a sequence. Does that make it difficult for anyone to find your address? The answer is no, because all these homes, they are located on different streets. While searching for any home, we will first look at the street name and then look up for the house number. Keep in mind the sequence. This is important. We first look for the street and only then look for the house number. Now, let us replace the street names with network address. Now, instead of the street names, we have networks 192.168.1, which is, let me just show you, which is here, and 192.168.2, which is here, and 192.168.3, which is here. The home numbers are the host addresses. So if someone wants to send a packet to home number 1, this one, in this network 192.168.1, then its address will show as 192.168.1.1, where the last number 1, it indicates the host address, and the first three numbers separated by dots, they indicate the network or the street in this case. Remember that here we are talking about the IPv4 class C address. We know that IPv4 has 4 octets or 4 numbers, they are separated by dots, and the first, by default, by the first 3, they represent the network. This can be changed, but we will not talk about it here. We'll talk about it in one of the future videos. Similarly, if it is a class B, then the first 2 octets by default represents the network, and in class A, it is the first octet by default which indicates network. Keep in mind what we said about network and host. We said that 192.168.1 is the network or the street address, and 1 at the end, that is the host or house address. The question is, who decides about the network and host, and how is the process to identify network and host? Let's have a look at it. Like always, that I say, computers they are very logical and they follow a very specific process to do anything, any computing, anything. Even while identifying network and host computers, they follow certain process. We need to be able to learn what the process is. This is really going to help you later when we talk about the advanced topics in networking, like subnetting. As you know, there are two types of IP addresses, IPv4 and IPv6. Let us try and find out how a computer identifies the network number and host number in an IP address. We'll start with IPv6. The address that you see here, this is an IPv6 address. We know that this IPv6 is 128 bits long. While using the best practice, the first half of the address, it indicates network. So when the router looks at the IPv6 address, it checks the first 64 bits to identify the network. Second half of the IP address indicates the host address or the computer address. Keep in mind that IPv6 is written in hexadecimal. That's very easy, you would say. Yes, it is when compared to IPv4. So how does the router find out the network and host address by looking at the IPv4 address? Let's have a look at it. Identifying network and host is slightly different in IPv4 compared to IPv6. This is the one that the address that you see here. This is an IPv4 address. Note that IPv4 is written in dotted decimal. This simply means that the numbers you see, they are in decimal numbers separated by a dot between 2 bytes. Do you remember what is a byte? 8 bits make a byte. If you have not watched that video, I would strongly recommend that you watch it. In IPv4, we use something called as subnet mask to identify the network and host. This is an additional number that is provided along with the IP address so that the system can calculate and identify network and host address. For class A IP address, the default subnet is 255.0.0.0. For class B, it is 255.255.20.0. And for class C, it is 255.255.255.0. The IPv address that we see above is a class C address. So the default subnet mask for it is 255.255.255.0. Keep in mind that this subnet mask can be customized. We will learn about it in one of the future videos. How does the subnet mask help us in identifying the network and host? Let's see it now. Let us first convert the IP address and subnet mask into binary. Remember that whenever we have any number, the computer has to convert it to binary so that it can understand it. And also remember that in IP address, the dot separates each byte, which is 8 bits. Do you remember the place value for each of these bytes? From right to left, it is 1, 2, 4, 8, 16, 32, 64, and 128. Now let us convert the IP address and subnet mask into binary. Let us start with subnet mask, which is easier. Basic rule for converting from decimal to binary is to find out, going from left to right, which place values can be added to get the value that is present in decimal. First, we will convert the subnet masks to binary. Let us start from the left. We know that for a byte, the place value is 1, 2, 4, 8, 16, 32, 64, 128. And if you add all these values, you get 255. That is why we will put 1 under all the place values, because we got 255 by adding all these numbers. So that's why you see all ones. This way we get all ones for 3 255s, all these 3, right? What about the 0 at the end? Well, that will be all zeros. So this gives us the binary value of 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1, again all ones, and then for 0 it's all zeros. All right, what about the IP address? Let us try to do the same. Take 192. Let us take the place value from left to right. 128 is less than 192, so we will use that, and I will put 1 under 128. Should we also add 64? What is the value that we get after adding 128 and 64? It is 192. So we will put 1 under 64 as well. Now that we already have the number 192, rest of the place values will be zeros. Thus the binary value that we get for 192 is 11000000. Let us take the next value, 168. To get 168, we will need 128 for sure. So let me put 1. What about 64? If you add 128 and 64, you get 192, which is more than 168. So we will not use this number. We will put a 0. What about 32? If you add 128 and 32, you get 160, which is less than 168. Let us take it and put a 1 against 32. We already have 160 and are short of 8. So, and we have this 8 number here. So let's put 1 against 8 and zeros against the rest. For the remaining, it's easy. We just need a 1 against 1 and 0 for others. This way in binary, we get 11000000 for 192. For 168, it is 10101000. For 1, it is 00000001, and the same for the last one. Now that we have converted the IP address and subnet mask to binary, let us see how subnet mask helps us identify the network address and host address. Let us compare the binary values of IP address and subnet mask bit by bit. So each bit against each bit. In the subnet mask, these ones, they represent the network, and these 0, they represent host. Now let us put a line where we see the last one in binary for subnet mask from left to right. Okay. Now let us look at the IP address. The binary number to the left of this line, they represent the network, and the binary number to the right of this here, this line, this represents the host address. In this case, the network is 192.168.1. Let us convert binary to the right of the line to get the host address. In our case, it is 1. This is the host address. Let's take another example for better understanding. Now let's look at an IP address 192.168.1.30 with the subnet mask of 255.255.255.192. To be able to find out the network and host address as before, we need to convert the subnet mask as well as the IP address into binary. Let's do that now. First of all, let's put the place values for a byte or 8 bits. From right to left, these are 1, 2, 4, 8, 16, 32, 64, and 128. We know that we will need to add all the numbers from 128 up to 1 to get 255. Okay, we will hence put a 1 for all the place values for 255. Let us now convert 192 in binary. We will add numbers from left to right. First, 128. Okay, we'll put 1 for 128. What about 64? What number do we get if we add 128 and 64? It is 192. So we'll put 1 for 64. As we already have the desired number, we'll put zeros for the rest. The subnet mask in binary is thus all ones for 255, 255, 255, and it's 11000000 for 192. All right. Now let us see how the IP address looks in binary. We already know how to convert 192 into binary from subnet mask. It is 11000000. Now let us convert 168 to binary. We'll need 128, so let's put a 1. That's here. What about 64? If you add 128 and 64, we get 192, which is more than 168. So we'll put a 0. And then what number do we get after adding 128 and 32? It is 160, which is less than 168. We need this number, so let me put 1 against 32. Now we need just 8, which is right here. So let me put 1 against 8 and then zeros against the rest. Okay. Now you get, if you add 128, 32, and 8, you get 168, which is the decimal value that we are looking for. For 1, this one, it's easy. We just need to put 1 against the place value for 1 right here. Okay. For 30, we need to add 16, 8, 4, and 2. All right. So we will put 1 against these and zeros against the rest. Now that we already have the binary values, let us compare these values with for IP address and subnet mask. Okay, let us place the binary values for subnet mask and IP address side by side and compare these. All right, Let us look at the binary value of the subnet mask and draw a line after the last one from left to right. As we know that the ones, they represent network, right? And then the zeros, they represent hosts. As you can see, the computer does this calculation to find out the network and host in an IP address. I personally find it amazing how quickly computers calculate the number and hosts while sending and receiving information. Alright, today we talked about the IP address and how it helps routers identify network and hosts so that the packets can be routed or sent correctly. As I always say that computers are very logical and they follow a step-by-step process to do what they do. If you understand this process, it makes things easy for you and you'll be able to troubleshoot things easily. In our next video, we will learn how to find out the exact network and host address. IP addressing is a vast topic. We'll be going deeper into it in future, exploring the other aspects. Thank you so much for learning with me today. If you have a feedback, please feel free to provide it in the comment section. Feel free to share it with your friends and family, and do subscribe for getting notified about new videos we post. At Accelerate, we work with students and startup companies in Canada by providing them with high performance and low cost computing devices to help them learn and grow. We help you own Dell laptops starting at just $400, and these laptops, they come with original Windows 10 or 11, at least Intel i5 CPUs, at least 8 gigs of RAM, which can be upgraded, an optional 1-year warranty, and a friendly post-sale support for your purchase. If you would like to know more how you can save on your next laptop purchase, do send us an email on the email that you see on the screen. Thank you so much for learning today. I will see you in the next video. Happy learning.